Okay, so here is your practice test number 3. Let me bring the mic a little closer. Something about that. All right, so this is practice test number 3, and we're just going to get started right from the beginning. Let's find a good blue to start with. Okay, given x is equal to 11.6 and mu is 23.1 and sigma is 3.8, indicate on the curve where the given x value would be. So in this case, you're probably just going to draw it out. So there's a curve. You know that mu is 23.1, so whatever's in the middle here is going to be mu equal to 23.1. You have a standard deviation of 3.8, so there's plus 3.8, plus 3.8, plus 3.8, minus 3.8, or mu minus 3.8, mu minus that one and that one, and x is at 11.6. So what we need to do here is take 23.1 minus sigma 3.8. Where's my calculator? Calculator. There's my calculator. So 23.1 minus 3.8 is equal to 19.3. That's the first sigma on the left, 19.3. The second sigma is going to be minus 3.8 again, which is what, 16, 15.5. So this guy is 19.3. This one is 15.5. Minus 3.8 again is going to give us 5,327. 4 minus 3 is 11.1. So this guy's 11.7. Given that x is 11.6, it's going to be just left of that 11.7. So this guy right here is going to be 11.6, way off on the left. All right. The point is, whatever this x is, if it was x is equal to 22 point whatever, 22.1, then it would be about here, 22.1, and you just draw it in. Shouldn't be that bad. Okay, calculate the standard score of a given x. The standard score is our z-score, and that's going to be x minus mu over sigma, so that's just plug and play. That's 91.3 minus 84.5 x mu sigma over 79.7, which is equal to 91.3 minus 84.5 equals divided by 79.7. 9.7, that seems like an awful big standard deviation, but our answer here is going to be, what was it? 0.085. 0.085, which rounds to 0.09. Excellent. Number 3, let's get some space here. Find the area under the standard normal curve to the right of this z. All right, well, there's no calculation to be made here. When in doubt, draw it out. Here's our normal curve. We have a mu somewhere. We know that in a standard normal curve, z is equal to 0 at the mean. So 0.078 is going to be over here somewhere. 0.78 is here. And we got to remember that we're looking to the right. So that's going to be all of this area over here. And at this point, we need to bring in our statistics tables. So you have a digital one. You can go to statistics tables A. Let me pop that out. And we're looking at the standard normal distribution. There it is. Let me zoom in a little bit. There we go. We don't want this side. Yes, we do. We have a positive z, 0.78. So now we're going to look for a z that's 0. Hello. Not that much. There we go. 0, 0.5, 0.6, 0.7, and we're going to walk this guy all the way out to 0.78. Let's see if I can move this. Minimize that. 0.7, and walk it out to 0.78. So our answer is going to be 0.7823. Save that for later. So this area here is 0.7823. No, it's not. This area, this 78.3, reflects what's on the left-hand side of the curve. So what we need to do is take 1 minus 0.7823, and that gives us whatever's on the other side of the z, which is 0.2177. 0.2177. Very good. Number 4. Find the area under the standard normal curve between 0.04 and 7.6. All right, there's 2 different ways to do this. We're going to just work one. I'm going to give myself some space here. Here's my curve. And under a z-curve, the mean is 0, as discussed, and then we're going to 0.04. So this guy's going to be 0.04, and somewhere out here on the right is 2.64. And the question is asking us what's between the z's. So we're looking for the area between here and here, so we're looking for all of this. And the way we're going to do this one is calculate the left-hand side of 2.64 and then subtract the left-hand side of 0.04. So let's go back to our tables and we'll grab them both. Let's put this over here. 2.64. Z, 2.60123, that's 9959. Let's write that down. So basically what we're saying is that the area from here all the way to there is 2.64. .9959. This is 0.9959. You know what? Let's draw it in the curve. It's not going to hurt us. So everything on this side is 0.99. All of this, all the way out to negative infinity, is 0.9959. And then what we're going to do is we're going to find what's on the left-hand side of 0.04. So let's go back to our table. Z is equal to 0.0, not 0.40, but 0.04, which is 0.5160 right there, 0.5160. Okay, so that represents whatever's on the point. I don't want to do it in green. Let's do it in pink. So that's going to be really ugly. Whatever's on this side of the 0.04, which is 0.5160. So we're going to subtract 0.5160, and we get the green. Back to my green. So that's going to be 9.974, or 0.4799. We figure out, again, the yellow is the left-hand side of 2.64, the pink is the left-hand side of 0.04, and we take one minus the other, and we get the area in between, 0.4799, and that is reflected right there. Same thing, let's give ourselves some space. Number 5 is very similar, but just a little different. We're going to draw this curve real quick. Big normal in the middle. This is a z curve, so this is 0 here in the center. And find the area of the curve left of 0.49 and the right of 1.91. So here's one, left is 0.049 here somewhere, 0.49, and on the right out here somewhere is 1.91. This is a two-tail test, so we are going to do the left side and then of 0.49 and then the right side of 1.91. So we're doing two calculations. The first one's easy, 0.49. 0.49 is 0.4 and then all the way to the right 0.6879. 0.6879. So this guy here is 0.6879. That's the area to the curve left of 0.49. And now we got to figure out the area on the right hand side of 1.91. So again, we go to the chart. 1.91, 1.91, 1.90, 1.91 is 0.9719. 0.9719. 0.9719. But that's the left-hand side of 1.91. We want the right-hand side of that. So we take 1 minus, and we get 0.0291, which means that this guy represents the area on this side. All we have to do now is add them up. So 0.0291, which is the right, and 0.6879, which is the left, gives us 0.717. Or 0.716. There's a rounding issue there. There's a little bit of a rounding issue there, but you guys can figure that out. And if not, we can solve it later. So don't sweat it. Okay, now we get to the more normal questions. The weight of the steers in a herd is normally distributed. Variance is 10,000, and please note that this says variance, not standard deviation. And the mean steer weight is 1,200 pounds. Find the probability that the weight of the randomly selected steer is less than 1380. So let's draw two curves here. Let's draw a first curve that has a mean of 1,200 pounds. And what is the randomly selected steer less than 1380? So 1380 will be over here somewhere, 1380, and you're looking for the probability of drawing it at one of these guys at random. This is a left tail test. What we need to do is convert this to a z curve. So we need to do a z transformation to get this guy and figure out what this z value is here. Once we do that, we can figure out what the area of the curve is going to be to the left of the standard normal curve. So we need to do a z transformation for 1380, that's our x, minus the mean, 1200, divided by the standard deviation. How do we calculate standard deviation? Standard deviation is equal to the square root of the variance. Our variance is 10,000. So let's get our trusty calculator up here. 10, 1, 2, 3. Do I have a square root? I do. It looks like a check mark. 100 is our standard deviation. Divided by 100, which is equal to, what, 180? 180 divided by 100, which is, what, 1.80. So this z here is 1.80. This should be relatively easy. Let's go to our chart. We've been lucky that we're all on the same positive table. 1.80 is 1.8. It's the first one right here, 0.9641. And that is our answer, 0.9641. So that area, the probability that you're going to get a steer less than 1380 is equal to 0.9641. Easy cheesy. Number 7, the weights of steers in a herd are distributed normally. The variance, again the variance, right? The variance is 90,000 and the mean steer weight is 1,100 pounds. Find the probability that the weight of the randomly selected steer is between 530 and 1430. Let's give ourselves some more space. So we can draw 2 curves here. Again, same thing. We draw 1 curve. We don't need to spend a lot of time. And we know the mean here is 1,100. So we're going to have something on the left-hand side, finally, 530. And something on the right-hand side, 1430. And we're looking for the probability in between these two, okay? Same thing happens on the Z chart, or the Z curve. Looks something like that. This is a 0. We need to find the Z associated with 530, and we need to find the Z associated with 1430. I'm going to start with 1430 because we're doing a between. I'm going to take this one and subtract it from the other one. So the Z of 1430 is equal to, Z is equal to 1430 minus the mean, right? We're doing x minus mu over sigma. And the mean is 1,100 divided by the square root of 90,000. So that shouldn't be too hard. It should be 300, but let's see. 90, 1, 2, 3, square root 300. 300. That is equal to, what is that? 330? Yeah. 330 over 300, which should be equal to 1.10. Let's bring out the calculator again. 330 divided by 300 equals 1.10. Excellent. 1.10. And before we do let's just go ahead and do the other one. Do it in red this time. Z is equal to 530 minus 1,100 over, I'm not going to calculate the standard deviation again. I've already done it. And that gives me, what is that? 570 divided by 300. And that should be equal to something like 1.8 or negative 1.8. Let's find out. 570 divided by 300 is equal to 1.90. Excellent. Negative 1.90. Okay, so let's go grab our tables. Here's our tables. And the first one's going to be positive 1.10. So that's positive, nope. 1.10 is 0.8643. So this area under, this area under the curve is equal to 0.8643, 0.8643. I'm running out of space here. That's better. And this guy, the negative, actually is on the other side of the page. So let's pull over to the left, because that's where our negative numbers are. Thank you. What was our number? Negative 1.90. Negative 1.9. This is negative 1.99. We got to go all the way to the other end. 0.0287 is the number that I'm looking for. Again, negative 1.9 and 0 at the top. Negative 0.0287. This is equal to 0.0287. I subtract 1 from the other, and I get a very nice and fancy, what is that, 13.4, and 3 is 5, 5 minus 2 is 3, 8 minus 0 is 8. 0.8354, 0.8356. Again, a small rounding error there. But nothing, I'll give you credit for that if it comes up. Number 8, A soft drink machine outputs a mean of 29 ounces per cup. I don't know where this is going, so I'm just going to write mean 29 ounces. The machine's output is normally distributed, check, with a standard deviation of 4 ounces. Sigma is equal to 4. What is the probability of overfilling a 33-ounce cup? There's no sample here, so I'm still going to deal with x's. This is 33. What does that mean to overfill? Overfill means I'm going to do something bigger than. Okay, so I want to find out if I'm losing money, if I'm losing coffee by overfilling greater than 33 ounces. So all of this space over here. My mean is 29. The standard deviation is 4. Similarly, we got to do that z transformation. So we draw another curve down here at the bottom where the z is 0, and we got to take this 33 and figure out what is this z question mark. All right, again, simple z transformation, x minus mu over sigma, which is equal to 33 minus 29 divided by 4. It makes it real easy when you do this. If you do this as you're reading the question on the right-hand side, it makes it a whole lot easier to plug and play once you pick the right formula to use. So that is going to be 4 over 4. The answer is obviously 1.00. And we're looking for the right-hand curve. So we go back to our chart. These are negatives. And I want to go from negative to positive. That's a little Biggie Smalls joke for those of you who are culturally illiterate. So 1.00 is 0.8413. 0.8413. So the probability... Oh, wait. That is the left-hand side. Right, so the z value for our chart is 0.8413, but this is a left tail. We don't want the left tail, we want the right tail. So again, we do 1 minus 0.8413, and the answer should be 7, 8, 9 minus 4 is 5, 1.1587. And effectively, that's what it is. Excellent. Yes, the dreaded professor grading question. The grading on the curve question. All right, we're going to make some extra space here. So here's the following schemes, A, B, C, D, and F. And usually, we're going to do these one at a time, so let's not get wrapped around the axle trying to draw the whole thing, okay? Let's just draw one curve. When in doubt, draw it out. Let's draw our curve. And what are they asking for? The scores are normally distributed with a mean of 73.3. Mu is equal to 73.3, standard deviation 9.7. Numerical limits for a B grade. Okay, so before we get all wrapped up, we're only going to focus on the B, this guy right here. And only the other ones. So we're looking for the scores below the top 5%. All right, I don't have Z values, but I do know that I want this percentage, and this is 0.05. And above the bottom 62%. So there's some other line. B is probably right around here somewhere. Well, I know it's on the right-hand side of mu because it's 0.62, right? What is the area on the left-hand side of the mean? 50%. And this is 0.62, but that's not what I want. This is not a two-tailed test. This is a no-tail test. I want the stuff in blue. These are all the B's. So I need to figure out what this is, and I need to figure out what this is. In order to do that, I've got to go to my standard normal curve, and let's figure out those Z's. Oops. Let's figure out those Z's. Curve looks something like that. All right, so this guy, let's do the one on the right-hand side first, and that's going to be 0.05. So the probability that x is whatever, greater than 0.05 means I don't have a z value. It means I have a probability value, and I need to find the z. I don't have an x. I got to figure out the z, and I'm looking for 0.05. So instead of looking at the z values, I'm going to look at the probability values and try to approximate it as quickly as I can. 0.05 doesn't appear on the right-hand side, so we have a problem, but not really, because we look for 1 minus 0.05 technically, which is equal to 0.9500. Let's see where we can find that. 0.90, 92, 93, 94, 957. It's not there. 0.9495, 0.9505. In this case, let's grab the 0.9495. We want to be inclusive, not exclusive, because it's a right-hand deal. 9495. And 9495 equates to a value of 1.64. 1.64. So my z for this guy, I don't know how to draw this, z is equal to 1.64 positive. Great. Now let's do the other one. We're going to do the same thing, but this one is a left tail, so I don't have to make any adjustments. We're just going to do the 0.62. So the probability that x is less than 0.62 is equal to some z, or I think it's like z given the probability of, or whatever. Let's grab it. 0.62, same thing, but it's going to be up higher somewhere. 0.65, 0.61, 0.6217. Here, I think the 0.6217 is closer than the other one, so I'm going to take this one and do 0, and note that my z is 0.31. 0.31. So this z is equal to 0.31. And that one I don't have to modify because it is a left tail probability, or left tail test. Okay, so now I'm not subtracting stuff. I'm just grabbing those z's and turning them into x's. There's nothing super fancy here. So let's just do exactly that. Z, this one is 1.64, is equal to x, which I don't know, minus mu. Where's my mu? There it is, 73.3. 73.3 divided by sigma, 9.7. And the other one is 0.31 is equal to x. Let's make this x sub 1. Let's make this x sub 2 minus 73.3 divided by 9.7. We'll do the same, pretty much the same calculation twice. More space. Okay, so this is, get some algebra going here before we bring that up. 1.64 times 9.7 plus 73.3. I'm just solving for x. This is x sub 1. And the other one's going to be 0.31 times the same, 9.7 plus 73.3, parentheses, is equal to x sub 2. So we're going to start here. 1.64 times 9.7 is equal to plus 73.3, and that is 89 point, where'd you go, calculator? 89.2. 89.2. That's x sub 1. X sub 2 then is going to be exact same calculation with a different number. 0.31 times 9.7 plus 73.3, which is equal to 76.3. So x sub 2 is equal to 76.3. What are our answers here? 76 and 89. Yep, we just did them the other way around. 89 and 76. 89 and 76. Very good. All right, let's keep going. Suppose the horses in a large stable have a mean weight of 911 pounds with a standard deviation of 1117. What is the probability that the mean weight of the sample of horses? All right, so here we have the word sample of horses. This kind of changes things a little bit. Would be greater than 891 if 45 horses are sampled at random. It's a great time to turn around and do your cheat sheet, right? What is the mean weight of the horses? 911 The standard deviation is 117. The sample of horses has an average weight, or no, we're wanting to know if it has an average weight of 891. That's my X bar. Would it be greater than 891? 891, and 45 horses are sampled, so that's an N of 45. I'm going to draw a little curve. There exists some mean, which is 911 pounds. 891 is over here on the left-hand side somewhere, and we want to know if it would be greater than. So what is the probability of picking a horse greater than all of this on the right-hand side? And greater than 891 is that guy right there. Okay, so clearly we're going to go from here to the standard normal table. All right, I'll go ahead and draw it. Why not? Right, and we got to figure out where the z is here, and then figure out the probability on the right-hand side of that. The mean is 0 on the standard normal curve. But there is a modification, because now we're not asking for an X. We're not asking for a single sample or a single draw. We're asking for a sample mean. And so our Z value has to be calculated a little different. Instead of saying X, we're going to say X bar minus mu divided by sigma, or the sigma of the sample, which is sigma divided by the square root of n. I have sigma, but I need to divide it by the square root of n. And that looks like 891 minus 911 over standard deviation 117. Sigma is 117. It's very nice when you can just grab it. 45, and it's already written out. Excellent. Let's go get our fancy calculator. Oh, wrong button. 891. We could do the denominator first because it makes it easier. 117 divided by 45 equals 2.6. So this is equal to whatever's on top divided by 2.6. 891 minus 911. 891 minus 911 is equal to negative 20. Well, that should have been easy. Negative 20. And that gives me a score of 10 something. It's going to be a huge Z. 20 negative divided by 2.6 is equal to negative 769. We did something wrong here. We did something wrong here. Yeah, and what we did wrong here was we didn't take the square root of 45. So, again, you got to be careful. You know, even your professors make mistakes. This is why we have a general understanding before we get started on these things. Square root of 45. That was our mistake. Let's go back and do it again. And that's why we started the denominator, because we can take that 45 and square root it first. Then we can calculate all the others. So that's 6.708. Go away. So that is equal to negative 20 over 117 divided by 6.708. I'll throw the other one in there as well. 2. Awesome. Where's our calculator? Come back. Okay, so 117 divided by 6.7082 gives me a denominator of 17.4413. 17.4413, and on top of that is my negative 20. That looks much better. 20 negative divided by 17.4413 is equal to negative 1.14, or negative 1.15 if you round it. So let's go out to the table. All right. We got to go to the other side. These are all positive z's. I need a negative z, negative z 1.15, 1.19875. Double check it. Yes, 1.15 is 0.1251. So the probability that x is greater than is equal to that x is greater than 891 is equal to I forgot. Negative 1.15, negative 1.15 is 0.1251. 0.1251. That doesn't seem right. And it doesn't seem right because this is, again, a left tail. And we don't want the left tail. We want the right tail. We want to know if something's bigger. Don't be afraid to take an extra minute at the end of the question and come back up to the top and say, what is it asking me for? What side? And this is greater than 8.91. I have gone out and grabbed this 0.1251, which I think is right, but I've got to come back and calculate it. So I need to get 1 minus 1.0000 minus 0.1251, and that gives me 874.9.87, or 87.49% chance that I'm going to grab a horse that weighs that much, 0.8749. Excellent. There we go. That makes more sense. Wait, how many more do we have? You guys are going to have to be on the ball when you take this test so you don't run out of time. Number 11. Oh, this one's easy. Okay. Oh, I'm still in red. I thought I switched it. All right, same thing as before. Mu is 83, so here's 83 somewhere. Sigma is 3.3, and so on. So we're going to the left. That is going to be, what is that, 79.7 is 1 sigma. From here to here is 1 sigma. And the x, which is what you're going to have to graph, is 80.2. So you just come over here and put 80.2 right in here somewhere. 80.2. No problem. Suppose a batch, not to be mispronounced, of steel rods produced at a steel plant have a mean length of 176 millimeters. Mean 176. And the, where were we? Where's my pointer? What's going on? What happened here? There we go. Oh, it's because I'm using the wrong one. Sorry about that. Okay, mu is 176 with a variance of 100. Again, variance of 100. Let's just go ahead and take care of that right now. Sigma is equal to the square root of 100. So we know that sigma is going to be equal to 10. Maybe that's something that's a good habit to get into and just double check that one. You can actually put variance, right? Sigma squared is equal to 100. You can write it down too. If 440 rods are sampled, ooh, we're talking about samples now. That 440 is what? It is N. We are sampling 446 rods. What is the probability that the mean length of the sample rods, mean length, would be less than 175.33? X is 175.35. Round to 4 decimal places. Okay, so quick graph. This one should be relatively easy. We know that the mean is 176. They're asking us for 175, so there's something just to the left. And mean length would be less. So everything on the left-hand side out to negative infinity. What is this probability? Excellent. So this is a z transformation, but it's for an x bar. So that means we're going to take sigma divided by the square root of n. Let's set that up. 175.35 minus 176 over sigma is 10. We've already calculated the square root of the variance. And n is 446. All right, let's do some calculator work. Calculator, see you later. Excellent. So 175.35 minus 176 should be 65 negative, or 0.65 negative. And 10 divided by 446 should be something really small. 0.02, 0.0224. 0.0224 in the denominator, and the top was 0.065 negative. So this is going to give us 0.65 negative divided by 0.0224, negative 29.0178. That's not right. So I took a moment to figure this out. I made the same mistake we did before. So let's back up this train. This should be the square root. Same mistake I did before. That's some of the problems. You got to make sure when you practice, you're practicing. Practice the way you play, right? Because otherwise you're going to goof it in the game the same way that you do it in practice. So square root of 446, 446, square root is 21. That's more realistic. So 21.1187. So the square root of n is equal to 21.1187. 10 divided by that, let me bring the calculator back up. 10 divided by 21.1187 is equal to 0.4735. Oh, okay, 0.4735. That's my denominator. Negative 0.65 is on top. And now I do the calculation with that one in the denominator. So 0.65 negative divided by 0.4735 equals negative 1.37. All right, that's more realistic. Equals negative 1.37. Excellent. So again, let's stop for a second and go back and say, is this a left tail, a right tail, or what? Less than. So this is a left tail. As a matter of fact, I've already drawn it because we're amazing. Good for you guys. Left tail. We bring out our book, which is about to expire. There it is. We bring out a book and we look for a z value at 1.37. So we're going to bring out the book, 1.37. These are negatives. Negative 1.37. Negative 1.37 or 0.0853. 0.0853 is our answer. Let's give ourselves a little more space. 0.0853. Anyway, I'll just draw it out here. 0.0853. And effectively, that's exactly what it is. So you see me make the same mistake twice here. If you guys identify what your mistake is that you're making every time, take the time to go back and practice those over and over, making sure you correct for your mistakes. You don't want to have that happen in the middle of the exam. Could be an issue. Racing car has a mean of 103 gallons of gas per race with a variance of 25. Again with the variance. Okay, so right from the beginning, 25 sigma is equal to 5. Mu is equal to 103. Sigma is equal to 5. 38 racing cars. N is equal to 38. You know you're going to have to take the square root. So let's just do it now. But if you do it, you want to write it down to make sure that you don't go back and confuse one for the other. 6.6144. 6.6144. 38 racing cars selectively at random. What is the probability that the sample mean X bar would be less than, left tail, 104 gallons. X bar is equal to 104.4. So this guy looks, you know what, let's move it over to the left because I don't have to make it that big anymore. Has a mean of 103. 1044 is on this side, 1044, and this is a left tail test. That makes it easier for us. Let's do our z transformation. So 104.4, or, x bar minus mu over sigma divided by the square root of n. Make sure we do that right. Minus 103 over sigma is 5 divided by the square root of n, which we've already calculated, 6.6144. 6.6144. Excellent. And this is 1.4 positive over 5 divided by 6.6144, 0.7559, 0.7559. Excellent. 1.4 divided by 0.7559 gives me a z-score of 1.85. So this is a z-score of 1.85. So again to the table. A little further to the right than I thought it was going to be, but let's get there. 1.85. 1.8. 0, 1, 2, 3, 4, 5, 0.9678, 0.9678, 0.9678, and our answer up here is 0.9582. Let's see what happened here. Do we have a 0.9582 somewhere really close? What is our z? 185, 185. 9686. That's not right. 9582. 9582 puts us at 1.73. Did I make a calculation mistake here? 1.5 minus 103 is 1.4. 5 divided by 6.614. The square root of 38. Did I make a mistake here? Let's find out. 38 square root is 6.1644. Oh, yes, I did. I wrote it down. I still made a mistake with the square root of n. Can you believe that? I can't believe it. This is 1644. Man. I guess I need more coffee. So let's back up the boat. That one's correct. This one is not. 6.1644. Woofa. 5 divided by 6.1644 is equal to 0.81. So this is 0.8111. 1.4, let's do this again, divided by 0.8111 is equal to 1.72. Yes, effectively, that's correct. 1.72 rounded up is 1.73. 1.73 is 0.9582. 0.9582. So we did the math right. We just made this mistake right here, and that cost us. And that's far enough away that I probably wouldn't give the respondent a rounding issue. Those rounding issues, when they come up early, really pay the consequences later. Let's move on. Test scores have a mean of 75.4. Mu is equal to 75.4. 10% of the scores are above 90%. 10% of the scores are above 90%. The way we write this is the probability of something happening are a 10 is the 10%, right? 10%. This is the probability of something happening. So now we have to decipher this scores above 90. So we're going to go X is my scores greater than 90. The probability that the scores are going to be greater than 90% is, or 90 points is 10%. Okay? Let me read that again. The probability of the scores being greater than 90% is equal to 10%. The scores have a distribution that is approximately normal. Find the standard deviation. Ugh. So here we're going to do the exact same thing we did before, but remember how we calculate our z, x minus mu over sigma. Here they're saying calculate for sigma. Instead of calculating for x, calculate for sigma. So I'm going to go out and find the z-score at 10%. There exists some variation, some distribution of scores where the top 10% of scores are 90. Okay, On the standard normal curve, I got to find out what's the equivalent of the 90. I don't have the z value. I do have the probability. That's 0.10. Let's go find 0.10. 0.10 on the right-hand side is going to be 1 minus 0.10. So we're really looking for 0.90. 0.93. Oh, that's close. We're close. 0.9015. This 0.8997 is closer, so I'm going to grab that one. It is 1.28. 1.28. So z is equal to 1.28. So I'm going to take the 1.28 and equate it to x minus mu over sigma. Let's replace some of this stuff. Again, give ourselves more space. 1.28 is equal to x. X is 90. That's the score. And the average is going to be, what was the average? 75.4. 75.4 divided by sigma. And then at this point, it's all algebra. But let's go ahead and do it together. 1.28 sigma is equal to 90 minus 75.4 divided by 1.28. Whoosh, whoosh. Divide by 1.28, and then we can do sigma is equal to, let's see, 90 divided by 90 minus, clearly I've got to clear the, 90 minus 75.4 equals 14.6. Divided by 1.28, 11.4625. 11.4625. What's our answer? 11.4. Excellent. Just a couple left. An operations manager at the electronics company wants to test their amplifiers. The design engineer claims that they have a mean output of 495 watts. Mean is equal to 495. With a standard deviation of 12 watts. What is the probability that the mean amplifier would be greater than 496 watt in a sample of X bar? Mean amplifier output dictates that we're doing a sample here. 496.1. N is equal to 88. Let's just go ahead and take the square root of n as long as we're here, because it's easy. 88 square root is 9.3808. Let's see if I can figure out how to not screw this one up. 9.8, bring it back up. 9.3808. 9.3808. All right. Would be greater, curve, I'm looking for something greater than x bar. This is mu is over here. So let's do a z calculation. And that's going to be 496.1 minus 495 mu over sigma 12 divided by the square root of n, which we've already calculated at 9.3808. 9.3808. Calculator, scoot it over. 12 divided by 9.3808 is equal to 1.279. 1.279, and that's under whatever this is. 496 minus 495 is 1.1. So again, we go to the calculator. 1.1 divided by 1.279 gives us a z-score of 0.86. 0.86 is our z-score. Great. Now, again, we've got to go back to the question and remember what it's asking us. Greater than. This is a right tail. Make sure you're getting the right tail, which means we need to get 1 minus the probability. What's our probability? I don't know. Just go to the z-chart. 0.86. 0 is going to be up at the top. 0.8. 0, 1, 2, 3, 4, 5, 6. Oops. 0, 1, 2, 3, 4, 5, 6. 0.7454. 1 minus 0.7454, which is equal to 0.2554. 2546. And we screwed it up again. Let's go back. I know all of this is correct, so let's go back to the Z chart. 0.86. Let's go grab that one again. Maybe we grabbed the wrong one from the table. We'll check your work. Blah, blah, blah. 0.86. 0.8. 0, 1, 2, 3, 4, 5, 6.8051. Okay, that was my mistake. 0.8051. 0.8051. So this is 1 minus 0.8051, which is equal to 0.1949. Is that correct? Yes, 0.1949. Oh, I'd kill for some coffee right about now. The mean number of words per minute typed by a speed typist is 123. Wow. 123 with a standard deviation of 14. What is the probability the sample mean would differ by the population mean by more than 1 word per minute if 52 sample type lists were randomly selected? All right, well, let's I don't know what this is, but I do know that 52 speed typists selected is my n. 52. If you want to do the square root, you can. Let's bring it up. Let's just knock that out. 52 square root is 7.2111. 7.2111. Okay, so let's back up now and figure out what it is that they're asking us to figure out here. What is the probability that the sample mean, x bar, would differ from the population mean? What's the population mean? This is mu. The sample mean is x bar. Differ means subtract. What are the odds that this would be x bar minus mu? I'm not seeing it. When in doubt, draw it out. So let's draw this out. And let's draw it nice and fat because I think we're going to be really close to the middle here. Here's my mean. And there's my mu. And my mu is 123. So I'm going to write that down, 123. What is it that the sample mean would differ from the population mean by more than 1 word per minute? So what is 1 word per minute more than the mean? It's 124. 124. But is this a two-tailed test? Does it also mean that it would be... Okay, so this one makes sense, right? 123... I add 1 more to that, and I'm looking for the probability that it would differ from the population by more than 1 mean. Now here's the tricky part. The tricky part here is when we look at the difference from the population mean by more than whatever, you're not looking at just the positives. You can also differ in a negative way. Whoops. You can also differ in a negative way. So this would be 122. Draw that curve and then fill in all of this. So this is at least 1 more or at least 1 less different and at least 1 for... No, this is a two-tailed test. Okay. The sample mean would differ from the population mean by more than 1. It doesn't matter if it's different bigger or different smaller. It's just different. And we got to take that into account. So this is a two-tailed test. And we're going to do the way we did before. But now it's going to get complicated. Not complicated, but just, busy. So Z on the left-hand side is equal to 122 minus 123 over sigma 14 divided by the square root of n. We've already calculated that at 7.211. Same thing on the other side. Let's call this C sub 1 and Z sub 2. This is going to be 124 minus 123 over 14 divided by 7.211. But this is a reflective question because we are the exact same distance away. Let me change colors here. Because we are the exact same distance away between here and here and here and here. They're both 1. The space on the left-hand side, this guy, whatever this probability of x is, it's going to be the same as this probability of x. So we don't really have to calculate it twice. You can. We can do all of this and calculate it 2 times. I am not because it's getting late and I got to go. So I'm just going to calculate this one. 122 minus 123 over 14, which is negative 1. I don't really have to do that. Negative 1 over, calculator. Oh, I closed it. Calculator. I don't want to use that one. I want to use my non-fancy calculator. Thank you very much. 14 divided by 7.211 equals 1.9414. 1.9414. 1.9414. And that equals to 1 divided by 1.9414. 0.5150 negative. Negative 0.5150. Negative 0.5150. That can't be right. Oh, yeah, that's a z-score, not the probability. Of course, it's right. Whew. Okay, so negative 0.510, 0.5150. Let's go find it. Negative 0. Let me say it this way so it'll make more sense. This is, I think that's what confused me. 0.51 or 0.52 because I'm rounding up. Okay, that's my z-score. 0.52, negative 0.52. So let's go down here to negative 0.5, 0, 1, 2, and I end up with 30.3015. Ever see that? Negative 0.30, negative 0.52, which gives me a probability of 30.5% or 0.3050. Let's grab that. The probability for this guy is 0.30. Oh, I lost it again. 15. Now, let's go up to the top real quick and look at this graph again. Okay, let me talk about what I mean here. Green. This space in green is 0.305115. 0.3015. Because this is reflexive, in this particular example, this is also the same. 0.3015. I don't have to go back and calculate it. So all I'm going to do is add these together or multiply them by 2 and get 6030. And if I scroll up to the top, I get exactly that, 6030. One more. And last but not least, the mean capita of, I have to erase this, don't I? Because you can't read it here. Okay, let's run this one again from scratch. I have an issue here. I don't think this is the correct answer. So if you've been working this and you don't have the right answer, don't freak out. Let's work it together and see what happens. The mean per capita income is 16,127. That's my mu. Oh, I'm doing it backwards. With a variance of 682,276. That's sigma squared. Let's go ahead and just calculate sigma as long as we're here. Calculator, where are you? 682,276. Square root is 826. Clearly somebody's done this one before. 826. What is the probability that a sample mean would differ from the true mean by more than, I don't even know how to write this right now, $104? If a sample of 476 persons, well, that one I know. I don't know how to write this. I'm going to write that right now. I'm going to skip it for a minute. N is 476. Okay. So this is definitely one where I want to draw it out. There's something weird going on here, and I've got to figure it out. It's very similar to our previous question, but I want to make sure that that's the case. The mean is 116,127K, and it's asking me how probability that the sample mean would differ from the true mean by $104. That means I'm going to go $104 left. Let's look at this previous question. More than 1 word per minute. No, yeah, that's right. $104 if a sample of whatever was selected. And then here's the other one. So between here and here we have 104, and between here and here we have 104. So we're going to figure out this X right here. All right. Let's get some more space going. We're going to need it. Okay, so let's do a Z calculation. Now, this is going to be X bar minus mu, but I already know what X bar minus mu is. It's 104, because it's telling me it's 104, over Yeah, I think this question is wrong. 104 over sigma. Sigma was 826. 826 over the square root of n. The square root of n is 476. All right. 476 square root is 21.87. Is equal to 21.87. So that's 104 over 826 divided by 21.87 is 37.76. 37.76, and that gives me, come back, 104 divided by 37.76 is equal to 2.75. That means my z-score is 2.75, and that's a negative z-score. Yeah, something's weird, but that's a negative because it's on the left-hand side. 2.76, 2.75. All right, let's go looking through the z-score. 2.75, 2.7, 2.75 is 0.0030. So that's the left tail. Okay, let's draw this again. Make sure that we understand. I guess what's happening here is that the actual X is much further out than we thought it was going to be, which means that this guy is much further out than we thought it was going to be. Okay, it's mu, X sub 1, X sub 2. I guess it is right. It's just weird with those numbers. Let's give ourselves some more space. And the chart tells me that this is negative 2.75, negative 2.030, and this is reflexive, so this is going to be 0.0030. If I add those two together, I'm going to get 0.0060. So yeah, no, that's right. 0.0060. That's correct. Okay, so good luck on your exam, and see you next week.